Now we're going to shift gears a little bit and talk about graphing a nonlinear inequalities and systems of nonlinear inequalities. So this video is going to be about graphing a nonlinear inequality, which is an inequality containing a nonlinear expression. So remember, an inequality greater than, less than, greater than or equal to, less than or equal to, nonlinear expression. So it could be something squared, cube, square root, cube root, so on. So here's an example of if you had a y greater than x squared minus 4. So it's your parabola, but it's strictly greater than, so it's not going to include the line, but it's everything above because it's greater than. Here we have y is greater than or equal to x squared minus 4, so it's everything including the line, so that's why it's not dashed. Here we have y is less than x squared minus 4, so the curve, you see it's dashed, so it's not including that curve, but it's all the stuff beneath it because y is less than. And then here we have y is less than or equal to x squared minus 4. So this one's going to include the line because of the equals part, and then less than is shading the graph below it. So remember, with an inequality, it's going to be a region, not just a line. So how to sketch the graph of an inequality bounded by a parabola. Graph the parabola as if it were an equation. This is the boundary for the region, that is the solution set. If the boundary is included in the region, the operator is greater than or equal to, or less than or equal to, or greater than or equal to, the parabola is graphed as a solid line. If the boundary is not included in the region, the operator is less than or greater than, so strictly less than or strictly greater than. The parabola is graphed as a dashed line. Test a point in the regions to determine whether it satisfies the inequality statement. If the statement is true, the solution set is the region including the point. If the statement is false, the solution set is the region on the other side of the boundary line. Then shade the region representing the solution set. So here we have y is greater than, so greater than means it'll be a dashed line, x squared plus 1. So x squared plus 1, as we've experienced, is going to be a parabola that just shifted up by 1. So we got points there and there. Normally 2 squared is 4. It's always 4. So normally at 2 would be at 4, but now it's going to be shifted up by 1, so it's 5. Same thing with negative 2. So we're going to get a graph something like this. I'm doing dashed line because it's strictly greater than. So I get my curve like that. And my gut is that since it's greater than, I'm going to shade above. But let's just find out. Let's just take a test point. What if we took the point 0 for x, 2 for y? So that means is 2 greater than 0 squared plus 1? So is 2 greater than 1? Yes, it is. So we would shade that side. So hey, let me try this. I've never done the shading with the highlighter thing, so not sure that's the best shading technique, but I guess it accomplishes the goal. Okay, that was kind of fun.